What up, my turnip garden? Welcome to the new lab. So today we're doing things a little bit differently because it has been a very busy week, like very busy. But as these things go, science is hard. So sometimes don't make it quite all the way through a project. So rather than doing nothing this week while we finish some stuff up, I thought I would take this opportunity to show off the new lab, and then we're going to do a little bit of live lab work, and then we're going to do a tour of the outside space, and of course I'm going to show you in here first. And then after that, shouldn't I be wearing a bunny suit? No, but then after that we'll do a little bit of Q&A, and we're also hopefully going to fire up Pipsqueak. So we'll get that set up in a little bit. So welcome to the new lab. And before you all freak out, I know I'm not wearing a lab coat. It hasn't arrived yet. So this is the only time that I'll be breaking this particular rule. But I am wearing shoe covers, not because this lab is ever actually going to be, magically wonderful, like mammalian safe, at least not for a little while until we build an airlock and a few other things. But more just the outside space gets extremely dusty, and people are coming in and doing like construction-y type things. So it's kind of just to help keep this space clean. And eventually I'm still waiting on a couple of the last pieces for this lab. But we're gonna have a UVC bulb that's gonna hang from the ceiling, so at the end of the night I can just turn that on and just sterilize everything. And also the air filter should be arriving early next week. So next week is going to be the video going through how I built this wonderful, wonderful space. But for now, we're just going to do a little bit of work. So while I talk, I'm going to be preparing some plates. So welcome to the lab bench. We're not doing anything super, super fancy right off the bat. I'm just making a couple of plates because I have, actually, you know what? I'm going to go grab them so I can show you. So I have this Petri dish. So growing on here is K. marxianus, which is a species of yeast that I'm going to be using for some future projects, which I'll talk about in just a moment. But I want to make sure that my culture stays happy. So to always make sure to re-streak a plate rather than just leaving it in the fridge forever. Why am I doing this? I'm doing this, like I said at the beginning, because we've been very busy with projects this week, and I want to do something a little bit different rather than just not having a video. So that's why we're doing this. And also, I thought it'd be a good opportunity to show off the new space, show off the outside lab, especially now that it's all clean after the construction of this space. We won't be working. So there've been a lot of people asking about, are you going to make a zombie apocalypse? No, I hope not. That would be bad, generally. No, this lab is specifically going to be for doing some genetic engineering, mostly of bacteria and yeast. So there's a couple different. So I'm starting with malt agar, just for those curious. Will I be doing gene therapy? Not in the near future, but we do have some other mammalian stuff coming up. We've been testing a method for regrowing hair. And this isn't something like we came up with. It's something that you can actually go to a clinic and pay for. But they'll charge you $3,000 when the reality is the materials cost all of $50. So, that seemed silly. So really all you need is $50 worth of materials and a case of beer for a nurse friend, and you can do the thing. So we figured, well, it'd be silly to, actually, let me put a little water in here first. So I've already got my water measured out. At the moment, I'm just using bottled water because our reverse osmosis filter hasn't shown up yet. But that'll be okay. So I'm just going to put a little bit in here just to sort of wet the bottom, because it makes doing this a little bit easier. Because otherwise, as soon as you put the powder in, it just kind of makes a mess everywhere. So we'll zero that. Zero, please. There we go. So I'm making 100 mils of media. So for this, that should mean I need 4 grams of powder. So I'm going to weigh this out. So back to the point of this lab. So I've had a bunch of genetic engineering projects that I've wanted to do for a very, very long time. Come on, wakey, wakey. And so the first one is going to be some. Why isn't this working? Wake up. Okay, there we go. So the first one that the big one rather, the one that I'm planning, is to make a version of spider silk grow in yeast. Now, this is not something super novel. It's actually been done many times before. There's a company, I believe they're called Bolt Threads or something, that is doing this for making actual fibers. But I don't actually care about making fibers. So rather than doing that, I'm actually going for bricks. So we're going to be doing a little bit of protein engineering rather than just pure. Why is this? Does the thing. I'm not a huge fan of the scale, I'll be honest. Okay, what's the deal? What? Okay, yeah, I can do the thing. So yeah, we're going to be doing a little bit of protein engineering so that it's rather than pure spider silk, it's going to be spider silk that has biomineralization peptides added to it, so that on contact with like mineral-rich water, it should actually grow into bricks. So it'll sort of be like a natural version of Kevlar and concrete, which I think will be really, really cool. So that'll be a lot of fun. I'm also planning a whole bunch of other projects. I mentioned in an earlier video that we were going to be doing some GFP modified yeast. And so I've just confirmed yesterday that the the culture that we have, which frankly is probably dead, the plasmid that actually makes it glow is not what's called integrating. So it doesn't cut a hole in the yeast's natural genome and insert itself. It just kind of floats around. So because of that, it means we can actually get that DNA back out. Wow, this is really taking an enormous amount. Come on, why aren't you? Okay, I'm calling it. This scale sucks. Well, that's okay. I ordered a new scale. This is just annoying, but this should be fine. So anywho, the GFP plasmid is floating around. So what we're going to be able to do is extract it and then put it back into some fresh live yeast. Oh, spilled a little. That's okay. So yeah, this is why I put a little bit of water in first. So now there's no powdery stuff stuck to the side. Yeah, this was totally enough. This scale sucks. That's okay. It was just the one we had. Yeah, yes, basically. So I've already ordered the selection antibiotic for the yeast. So that'll be really great. Basically, it's just called gentamicin. So all we're going to do is we're going to take the plasmid out of the dead yeast, put it into some fresh yeast, and then use the gentamicin in the media, which is this stuff. Although we're not doing this today. I just ordered those supplies. So yeah, once we have that, then we'll be able to make some fresh glowing yeast. And then for Halloween, we're going to be brewing a very large batch of glowing beer. We do a lot of brewing here, which, by the way, in case for anybody wondering, I'm working out of Foo Lab, which is a hackerspace in Montreal. And it is open to the public on Tuesdays and Thursdays. So if you would like to come and see the things that I do, you're welcome to come in on those days. Also, I'm going to be leading a couple of workshops in the next couple of weeks, and I'll be posting more about that soon. So since the scale is kind of janky, I'm only going to actually make the one tube. I was planning, or the one flask. You can see how dark that is. That is way more concentrated than I was hoping, because this scale just refused to work. So that's kind of frustrating, but is the way it is. It's not like this stuff is particularly pricey. It's just agar and malt. But yeah, so if you would like to come and see the things that I do, and come in and chat and see the workshops I will be posting more about in the next little bit, once we've finished outlining them and getting all of the stuff that we need. I'll be posting about when those will be happening. So if you're local to Montreal and you want to come and be taught some stuff, I will be doing that shortly. Also, I'll be live streaming all of those workshops, so if you aren't local, you can still see them. Speaking of FooLab, if you like the things that we do, of course, if you like my channel, then you're always encouraged to go over to the Patreon and consider becoming a patron, because I make a point of everything that I do is put out for free. So I try and take inspiration from the guy who invented the polio vaccine. He could have patented it and made millions, but he decided it was more important to give it out for free. So that's something I try and embody as well. So if you like open source science and the things that I do, becoming a patron is always great. Also, if you like FooLab and want to help make sure that this space stays open to the public and doing all the cool, amazing things that happen here, you can go to foolab.org, and there's a donate button. I would highly encourage you guys do that. Every little bit helps, and paying rent is important, because can't pay rent, can't have a lab. So that's always something. Donate butter. I mean, please don't donate butter. Please donate money. That's way more helpful. But yeah, so yeah, 10% agar solution. Yeah, I know, right? This will clear up once I autoclave it, which we're going to put this in a moment. But we will come back to that in a moment. But yeah, so while I'm in here, let's give you a quick little tour of the space. There we go. So you can see I'm wearing my shoe covers. But anywho, so this is the main work table here. It's a little bit messy just because I'm working, but got all the basics. We're waiting on a couple little pieces of equipment. Then over here is all of our shelving. We've got all our supplies and reagents and kits, and we've got a lot more stuff coming in. At the bottom, you can see all of my high vacuum stuff, sort of peeking out. We are going to be putting that to use hopefully soon. It's just been getting this lab built has sort of been the main focus for a little while. So there's still a few things that need to be built, just because they're just too expensive to buy, and also it'll be a great excuse to show you guys how to make some of the hardware required to work in a lab like this for a couple of bucks instead of a couple of hundred. So we still need an incubator, so that's gonna sit on top of the fridge over there. But I was just given this really, really cool piece of kit, which I will show you right here. Let me just clear some of this stuff out of the way. But yeah, there's going to be so much stuff that's coming out of this lab. That's one of the reasons why I took the time to make it. It was like, even though bio is expensive to me, it seemed like it was worth the investment. So I was just given one of these, which is really neat. There's a piece that sits on top. So it's called a bento lab, and it's really neat. It's kind of like an all-in-one bio piece of hardware. I don't know. It'll make sense when you look at it. So it has a transilluminator and connections for electrophoresis. It's got a little centrifuge, little PCR. So this is going to be used. We're probably going to give it a paint job because this is a really old version. Might also tweak the firmware a little bit. Who knows? Maybe we'll make it play Come All Ye Faithful. But either way, that's a cool little piece of hardware. We'll be putting that to a lot of really great use. And also I love that it's got the transilluminator instead of having to use like one of these little dinky things. But yeah, I'm still waiting on a couple of supplies, which is sort of why it'll be a little bit until we actually start doing some really hardcore bio stuff. Because, I have a gel box, but I don't have stain yet. So we wouldn't be able to, find where our DNA was. So that'll be good once all of that stuff arrives. And then, of course, our antibiotics so that we can do selection and all that sort of stuff. But yeah, I mean, bio is kind of really expensive. But the nice thing is there's a lot of overlap between the things that you buy. So, if you buy an enzyme, one of the other organisms that I have is a species of bacteria that will outcompete the bacteria in your mouth. And this is important because if you knock out their ability to produce lactic acid, or like digest whatever it is that gets turned into lactic acid, honestly, I forget. So you knock that out, and then you add in the gene to do alcohol, if you knock out lactic acid, and then add in alcohol dehydrogenase so that they can produce ethanol as part of their, food or their metabolic process. In theory, you end up with a bacteria that will outcompete the bacteria in your mouth, and will also only produce ethanol, so it won't produce lactic acid, so it won't mess your teeth up. And they've actually tested this on a bunch of rats where it actually like dropped the number of cavities and stuff significantly. So that was really cool. So we'll probably be going through the process of doing that. But the reason I bring it up is because the enzymes required to do that are also super, no, you won't get drunk. The enzymes that are required to do that are the same that you use for a lot of other procedures. So it's like monk bean nuclease, which is just really good for breaking down single-stranded DNA, or trimming off the sticky end after you use a restriction enzyme. So that'll be really good. So while we're here, I'm going to answer a couple of questions. Am I a scientist? Yeah, obviously, in a lab. It's always funny when I was a kid, people would ask, what do you want to do when you grow up? I'm like, I want to be a scientist. And they're like, what kind? And I'm like, did I stutter? Like, scientist, period, full stop. I'm not an insect. I don't specialize. So I kind of have made it a point of keeping my interests extremely broad, both because it lets me work on a very wide range of stuff, but also because there's a lot of interplay. And this is, at some point, I feel like I'll probably do like a philosophy of the Thought Emporium. I'm only ever going to do it once because not a philosophy fan at all. But I have noticed throughout all my years of doing all these different things that there's an enormous amount of overlap between the various fields of science. And one of the things that was always extremely frustrating was there's a lot of like over specialization, especially in academia, where like people know their one thing and one thing only. So they spend, 4 years on the same thing trying to, figure out how to make it work, when the answer is you need to like broaden your scope a little bit and look. Socrates just on something. You got to broaden your scope a little bit, and then the answers to whatever it is you're working on tend to show up. So it's like if you only work on nanoparticles but are ignoring, like aptamers and lasers and radio and all this other stuff that let you interact with the particles are useless. Or et cetera, et cetera, et cetera, et cetera. Like I could go on for hours, but I won't. Point being, there's a lot of overlap to science. And so I've tried to kind of embody that in my learning over the years. So, I'm self-taught in nuclear and all the physics stuff, but I did go to school for biology. For those wondering, and I've talked about this before, I went to Carleton University. Wouldn't suggest it. At least not the bio program. They do population genetics, not really like genetic engineering, which was for me very, very frustrating because that was the one thing I wanted to learn how to do. So all of my genetic engineering knowledge has come from working with professionals, working in professional labs, and kind of actually getting my hands dirty and doing the thing, and that made all of it make a lot more sense. So that was kind of that. And as in terms of like, are you a scientist? There's this really, and I've talked about this before, but I'll talk about it again briefly. There's this really, really annoying sentiment wherein if you don't have a degree, you can't be a scientist. Or if you're not working in an academic lab, you're a citizen scientist. Fuck that. No, absolutely not. I draw a very firm line on you're a scientist based on the quality of your work and the work that you do and what you put out. So it doesn't matter if you have a degree or not. If the work that you do is good and reproducible and actually up to the standards of every other scientist everywhere else, it doesn't matter what stupid piece of paper you have. Because the number of people who have degrees who I can casually like walk circles around and have no it's frustrating. Especially because traditionally the definition of a scientist was somebody who had the time to do science. I mean, it was usually like dukes who had tons of money and nothing better to do. So they would just, study things or monks because they had nothing better to do. So that was, yeah. Anywho, so I'm a big proponent of anybody can do science. Just all you got to do is put in the time and do good work and, make sure that you learn the thing before you hop into them. But yeah, and there's people cheating to get their degrees, and there's also the ever fun joke. What do you call somebody who finishes last in med school? Doctor. So, just having the booping stick does not actually like set a bar much. It means you can pass exams, and like insofar as I never actually went to my classes, I would just like learn the entire course a night or two before the exam and then do fine. I was like, well, this is dumb. Like, you're just making me do grunt work. Why am I paying for 4 years of grunt work when like, especially, and the thing that really, really, really drove me nuts was, every year they would teach you the same things again, but with just a little bit more information. And it started in like grade 11 when you started really doing biology. And then in grade 12, we did the same content again, but we just had to like learn a little bit more detail. And it was so annoying. It's like, just teach me the thing from the get-go, and then I don't need to like relearn it 15 times. Just teach me the stuff, be done. And there's also this like perception that kids can't handle that level of information. Bollocks. Like, I know a lot of extremely smart kids who are able to do amazing work. Their age is irrelevant. So I don't know. I think there's definitely a lot of potential that's sort of wasted in exchange for doing a lot of grunt work. PhDs isn't about passing the exam, doing research. True. However, you can get a PhD in a lot of things and you still get a PhD. So doesn't really matter how exciting or wonderful your research is. Your research can still be shit and they'll still give you a PhD. Not to say all PhDs are bad. I think there's a lot of really great PhDs and people who've worked very, very hard to get their degree. However, if you're just counting pollen, I don't really give a shit. And to those of you who are worried about swearing and stuff, sorry in advance, but for live streams, I'm going to kind of speak how I normally speak rather than the sort of sterile script that I tend to go with for the more prepared videos. But yeah, so I think that's kind of the basics of the biospace. You've seen it. It's not a huge space, but it doesn't really need to be. And also, I've explicitly left a whole bunch of areas of kind of open space so that there's room to grow. So if we want to add more equipment, we're totally able to do that. And also, the nice thing about a space like this is that it won't just be for biology. It'll be for anything that needs to be clean or relatively dust-free. So I think that will be a really good place to do this. So like the next laser video will be done in this room because then it'll be dust-free. It'll be, dehumidified. All the air is going to be through a HEPA filter. You can see that the door has lovely weather sealing. This place really is going to be fairly airtight. And once we've got positive pressure, the only air in here, other than when you quickly open the door, is going to be really nice and dust free. And with the UVC, all the dust is literally just going to fall off the walls. We'll be able to clean it up, and then it'll stay really nice and clean. So that'll be great. So it's not super clean yet, just because we literally just finished building it. Literally making this like flask of media is the first thing that I've done in this lab. And can I just say I am excited for the possibilities. I don't have a UV light yet, but it is coming. I've mentioned that a couple of times. It's going to be, we're going to hang it. We might even have like an automated motor. So it kind of like moves up and down in the room so that it kind of hits everything, just so that there aren't like little nooks and crannies that are sort of getting away. Just quickly, because I've answered this 18 bajillion times at this point, but I'll continue to do so. Yes, the lactose thing is still working. My breakfast was cream cheese. It worked well. I'm not dying as far as I can tell thus far. But yeah, that's that. Other bio projects that are coming up, there's a lot that we've been kind of planning out and getting ready. So I'm really excited, honestly. There's once the silk thing is underway and we've got all that, because the silk thing actually has a whole bunch of pieces. So just getting the silk bricks growing is only part one. It will continue to, we'll continue to modify the gene and improve it and do all that kind of stuff. But once the silk project is underway, we're thinking that the next project is actually going to be one that is cancer focused. So there's a team in, I want to say Denmark, I don't know, somewhere in Europe, where they're working with a protein from malaria that they found will stick to like 95% of cancers, which is really, really interesting. So they've already cooked up a blood test that basically lets you just take a blood sample and test it for like 95% of cancers, which is really cool. They are going real hard on the patents though. So I think this is a really cool concept, and I want to see if I can make my own. And if we have that gene working, there's all sorts of things that we can do with it. We could try and make our own like CAR T plasmid, which could be amazing and super interesting, and I think a really great teaching opportunity. But that's a really big project. These are the kinds of things that we'll be working on, over time. So there's a question about we. So there is actually a lot of people who are involved both directly and indirectly. Because this is a hackerspace, there's other members than me. So I make ready use of the other members when I get stuck, because I'm not some like magical super genius. I just try and surround myself with people who are extremely good at what they do and can fill in the holes and gaps in my knowledge. So, I might be able to, build a robot. I can't program one. So I make use of the very talented coders who love to hang around. And I do. It's the same with biology. For those wondering, I'm still involved with SciHouse, at least from a more superficial, just kind of if they need help with some research stuff, just because I'm not in Florida anymore. So the things at SciHouse are also going very, very well for those curious. They're still doing lots of mammalian work, and there's a lot of really great stuff that's going to be coming out of that lab, which I think is great. But yeah, all the bio stuff is, I think, going to be really, really, really great. There's so many projects that we want to do. There was somebody asking about CRISPR. Personally, I think CRISPR is a very interesting tool. We've worked with CRISPR before. It's neat. There's a lot left unstudied with CRISPR because it's brand new. Every headline is getting like foaming at the mouth, excited about CRISPR, but it's just a pair of scissors. It's not gonna like magically change the world. It's still like fiddly to get working properly. There's still a bunch of requirements for it. And also, CRISPR is the name of the system. The actual enzyme that does the work is Cas9, or at the very least, that's the one that everybody's been studying. Thing is, there's a Cas protein in millions of different kinds of bacteria, which means there are fundamentally millions of different Cas proteins. And we're finding that each one kind of does a little bit of a different thing, and some are better than others. Everyone's studying Cas9. Personally, I like Cas12. And there's some really technical reasons for why, which I won't get into right now. But So for those wondering, yeah, sure, we'll mess with CRISPR. There's been a couple of people around here that have been asking to do some CRISPR stuff because they think it's neat. And I'm like, yeah, sure, why not? You can get CRISPR plasmids on Adgene for like $60, and then you can play with CRISPR. And all you got to do is just change the targeting sequence out, which is great. Site-directed immunogenesis is better for very specific things. I mean, this is the thing. It's like it's a tool. It's like a wrench. Like wrenches are very, very good for bolts, not so good for nails. You use the tool for what it's best for. So that's that. We will be exploring all sorts of stuff. I've got a friend who does really amazing work with fluorescent proteins. So as soon as he puts out those proteins, I am absolutely going to get my hands on it. And also, I already have a GFP protein, which I talked about a little bit earlier. So once we have that, we can do mutagenesis experiments. So that'll be a really cool video in and of itself, where we basically just run PCR over the gene with a tiny little bit of manganese mixed into the reaction mixture. And this sort of makes the reaction a little bit imperfect. So it actually induces a whole bunch of mutations. So you can end up with proteins that are wildly different colors, because just by changing a couple of amino acids, it shifts the structure a little bit. And instead of, say, vibrant green, you get vibrant blue. And, there's all this other stuff. So that guy has made a phenomenal blue, red, and green protein and is now looking to, go for the whole rainbow. I look very forward to the day when those proteins are available because they look super neat. And, he wants to express them in flowers. I would love to express them in all sorts of things. I mean, adding that to the silk, for example, would be super cool, because then not only are we growing bricks, we could grow colorful bricks. We could grow the yellow brick road, So I don't know. That's one of the reasons I've always loved biology, is because it really messes with your concept of what's possible. Because fundamentally, and I'm stealing this line from my friend because it's a good line, but fundamentally, biology is the ultimate way to transform one form of matter into another. If you think about it, you're basically soggy bread. Which is a weird concept. We're all just what we eat, but our biology is a phenomenal way of taking bread or cheese or whatever else and turning it into all these different interesting, proteins and minerals and, all this other interesting stuff. So, because of that, biology really lets you truly, it's hard. I need to be really upfront at this. Doing biology is hard because you're fundamentally fighting with things whose, all of our tools, all the enzymes that we use for, doing any kind of genetic engineering work, we stole from bacteria or yeast or plants or whatever else. So if we go to modify them, fundamentally, they're better at it than we are. So if you modify, say, E. coli, you can only keep that E. coli for so long before eventually it'll go, thanks for the antibiotic resistance, I'm going to keep that. Get rid of whatever other nonsense you've put in here. Have a nice day. And then you got to start again. So, or you do something wrong and then it just dies and you get to start again. I've told the goat story before. It's never fun. So, biology is hard, but it's worth the time and it's worth the effort. And it really lets you be creative and make amazing, amazing things. The concept of growing bricks. That's just what kind of nonsense is that? But it's totally a thing that it could be done. So, once we have that GFP plasmid, maybe we'll put it in some bacteria and make some glowing pickles. Because why not? Because we can. So it's just kind of an interesting thing. But also, biology has the potential to do a lot of good. Because there's a lot of people who just kind of want to do it to be showy. I would prefer to have it have some impact. There have been a lot of people who've been asking about the plastic-eating fungus and the styrofoam worms. We are coming back to those projects, but now that I've got a proper lab, for the styrofoam worms, for example, we're going to see if we can culture the bacteria that actually do the work in their gastrointestinal tract. So this can mean, we're going to have to dissect open one of the worms, culture the bacteria, streak it, test all of them, see which ones can actually break down styrofoam, and that'll be really, really great. then we can go from there. And, if we end up with a new bacteria that's able to do that, then maybe we just have a bucket where if, when you want to throw out your styrofoam, you just throw it in the bucket and it turns it into bacteria goo. Could be neat. But, that's all stuff that is possible now that we have this lab. So all that kind of stuff will be coming. So I think that's enough bio for now. I'm going to just take a quick little look-see at the comments, see if I missed any interesting questions. And then after that, we're going to go for a tour of the rest of the space. Yep, you can check out Food Lab on Tuesdays or Thursdays. Those are the open days. People usually start getting here around 6, maybe a little later, and people are here usually until around midnight, sometimes later. Most people go home when the trains stop running, so that's around midnight. So yeah, if you're interested, again, if you're local to Montreal, Food Lab, Tuesdays and Thursdays, feel free to drop by. And also, if you want to help support the lab itself, then go over to foodlab.org and hit the donate button. Every donation is appreciated. Helps pay the rent, which is important because no rent, no lab. So that'll be really great. Also, on the topic of donations, again, if you want to support the show, then go over to my Patreon, become a patron. I'm going to be changing the reward tiers shortly. It's very difficult to do all of the science stuff and consistently keep up with rewards and all that. So I want to make sure it's things that you will all value and enjoy, but also that I can be sure that I'm going to be able to fulfill, because I don't want to cheat you. That's no good. But yeah, so if you want to do any of that, that would be great. Okay, a couple of quick questions, and then we're going to head out to the rest of the lab. It's a little more noisy out there, which is sort of why I've been doing all the question and answers in here. So there have been a bunch of questions about all sorts of radio stuff. The satellite thing is legitimately what we've been working on all week. This is why there's no video, but unsurprisingly, it's sort of a difficult thing to do because the satellite is really freaking far away. And also the software has been not playing nice. So that's kind of been what has been going on. But we are this close theoretically from getting an image off of GOES. We can see the signal consistently. We can find it no problem, super easy. Even on the program, it's telling us that we're getting packets, but for whatever reason, it won't send those packets to the other part of the program that actually turns them into the files that become readable, that we can actually do stuff and get our images off of. So that's what we've been fighting with. I'll show you the antenna and the setup. Of course, we'll see it in more detail when we actually make that video, which will either be next week or the week after, depending on when we get it to actually finally work. And then once we get it working, the software that we've cooked up to actually make it do the thing will be put out so that other people can do it as well. In terms of, yeah, I mean, it's called GNU Radio, which is Paul just yelled at me through the other room, because we're basically simplifying it or attempting to simplify it so that rather than it being a whole bunch of different pieces that all have to work together, it's all just done in GNU. It's all one self-contained thing, which should be really good. Okay, let's see, other questions. There's been a couple of questions about paywalls for scientific articles. Now, I would never condone piracy. Piracy is bad, but paywalls are bullshit. So I'm not going to suggest that you go to scihub.tw, but go to scihub.tw. Again, piracy is bad and illegal in some places. But keeping in mind that scientific publishers don't actually pay the scientists. Scientists have to pay significant amounts of money to get their paper into a journal. So it's not like you're cheating the scientist out of money they would get. They have to pay enormous amounts of money. If you want to submit to, say, Nature, I think the cost was $100,000 or something. It was $3,000 for them to look at your paper and then $100 for them to publish. It was ridiculous. So if you go to Sci-Hub, you get access to every paper that's ever been written, which is wonderful and legitimately one of the best things to happen to science in a very long time. And they've actually been, the reason they do that thing is to force publishers to switch from paywall bullshit to open access, because they know that they're going to be, potentially screwed out of their viewership because they know that if there's a paywall, they'll just go to Sci-Hub. That was always the main purpose of Sci-Hub. It was literally just to like force the publishers to stop being dicks. So yeah, if you want a paper, Sci-Hub is your way to go, but don't tell them I told you. Also, I don't condone piracy. Bad. Okie dokie. Moving on. What else we got? Quick question about the UVC in here. We're going to be getting black curtains to cover the walls from the outside for when it's running. And also, nobody's going to be in the lab when I run it. Like I'm usually here later than everyone else, so I'll run it at like 2 a.m. and I'll stand in the other room while it's doing its thing, and then run over, hit the switch, and that'll be that. But also we're going to get curtains to make sure that extra super mega safe, just to be sure. Anything else? No, I don't. Question about the magnets. No, I don't have a magnet in my finger. When my friend did it, he didn't quite close the wound properly. But now that we have this wonderful clean biospace, actually. That's why I have this. So I'm gonna put another one in myself because I know that I can do that right. But anyways, that is that. Okie dokie. Yes, the UVC is probably going to degrade the plastic. It's cheap plastic. That's fine. Also, there's 2 layers, which it's hard to tell from in here, but this is double layered. So it's in panels. So if at any point we've got to replace a panel, we totally can, and it costs us functionally nothing to do it. Ozone, yes, I know there's going to be a whole air system in here, so the air is going to be circulated very, very quickly. It'll be fine. Have I done astronomy? Yes, I love astronomy. I don't currently have a telescope because I had to leave it back in Florida, but I love astronomy, and it kills me that I don't have a really nice telescope, but at some point we will. The mouth bacteria, I'm probably not going to test on myself. Yeah, I don't know. Not sure how we're going to test that yet, but that's like way down the line, so we'll figure that out when we get there. Yes, we're getting fire extinguishers. Yeah, we're going to get like a warning sign. Like these are all things that we've already thought through and are planning and making sure that that's going to be a thing. Yeah, I mean, we have fire extinguishers, but we're going to get like a designated in the lab fire extinguisher. Also, I'm kind of making a point of not using anything flammable in here other than like a propane burner for sterilizing loops. Instead, we're going to be using Chlorhex because chlorhexidine is wonderful and also water-based. So then we don't need to, fumigate ourselves with ISO because that's only as fun as it sounds. Okie dokie. What else we got? Yeah, I'm not getting Halon for in here. Yes, we are going to do work with the fungus. I mean, strictly speaking, yeast is a fungus, and I have yeast, and we'll be doing a lot of yeast stuff. But also, we're going to get other fungus stuff too, just because that's neat. Somebody just asked about, Jesper just asked about cold plasma. That is, we're like this close in theory. We've got the amplifier for it. We just need to put a little bit more power into it, and then we got to deal with the gas handling system and all of that stuff, which I think will be really, really cool once it's done, because it's going to be how we sterilize things in here. Like, because it's quick, it's cheap, and it works extremely well, and I don't need to like wait for solvents to dry, which is awesome. So, when we've got a thing of Petri dishes, like the bag's been open and we're like, on whether or not the dishes are okay, we can just hit it with the cold plasma, clean it right off. It'll be perfect, which is going to be amazeballs. Also, it's cold fire, so you can like touch it and be like, look, I'm touching fire. So that's neat. You're getting banned for that. Fuck off. Bye-bye. Anywho. Project you want to do but can't. Oh yeah, projects I want to do but can't because of lack of materials. So many. Like at the moment, I'm still figuring out what I'm going to do about a spectrophotometer and, I mean, really, if I had a nano drop, it would make my life so much easier. But they're just so inexpensive. So if somebody has a nano drop that they're not using and would like to donate one, I will happily take that off your hands because nano drops are amazing. But other than that, I mean, it's all just like harder bio stuff for the most part, or like physics stuff that's just expensive. But yeah, so many SDR things on the horizon, like so many. Like we're thinking of radar and X-band stuff, and because basically like we've been thinking about like, okay, well, if we wanted to do X-band, which is in the range of 7 to 12 or 7 to 10 gigahertz, depending on where you draw the line. There's a lot of satellites up there, and some of them are possible to get actual data off of them, and some you can just see the signal, and even just seeing the signal is cool. We're talking the Parker Solar Probe, like all of the major space like telescopes, all this stuff is all in the X-band, and so at the very least we'll be able to see the signal. So like seeing a signal coming off of, say, Juno means we're seeing a signal from frickin' Saturn, which is awesome. Or Saturn, Jupiter. But I mean, we'll need a bigger dish and all kinds of stuff for that. We're also going to be working on some new antenna designs. There's these really cool things called slot antennas, which we're going to finally get around to making one. We're going to look at passive radar, active radar, all this amazing stuff. But, you know, that'll be interspersed in amongst bio stuff and physics stuff and all this kind of stuff. Because, like I said, I'm a scientist. I do everything. Okay. One or two more questions, and then we're going to go outside. Okay, first. To the Brazilians who have been asking when and why I was in Brazil. I was in Brazil 2 Februaries ago, 2 years ago. I don't know. It was a while ago at this point. I was teaching a course. It's kind of it. I was only there for like 2-3 months. It was fun. It was interesting. It was very hot. And the place that we were in had higher biodiversity than the Amazon, which was really neat. But, you know, I wasn't there for very long. My Portuguese is god-awful, but in fairness, Portuguese is really freaking hard and unbelievably tonal. There's a lot of stories I could tell about that, but that's for another day. Okay, let's... the Hair project is getting continued. We're just waiting on a couple of things for that. No, passive radar is non-transmitting. You're just using signals bouncing off of other stuff. When we do active radar, it'll either be extremely short range. Oh, there's the car. It'll either be extremely short range, so it doesn't interfere with any, like, low power, so it's not interfering with any laws. But also, FooLab is a ham club, which means we're allowed to design and test and build stuff, which is great. Also, I'm getting my ham license. I've chatted with Styro. He's a great guy. Hopefully we'll set something up at some point. We're just both very, very busy, and finding compatible projects is hard. What else? Yeah, Portuguese is unbelievably difficult. And all of the words, like, at least in Brazilian Portuguese, all of the words for dick and all of the words for bread are basically the same, which ends up with a whole bunch of very funny instances, which was entertaining, to say the least. Number of times people weren't ordering cheese bread. Anywho, so I think with that, we are going to leave the lab and go and first get our media into the autoclave, although I'm contemplating diluting this a little bit because this looks kind of dank. But we'll see. In fact, you know what? I think I will. I'm going to add like another 50 mils to this. The nice thing is, if it's a little dilute, it's not the end of the world. Okay. My thing has a tinfoil hat, which means it is time to go into the autoclave. Now, I kind of hate running the autoclave for just like one little flask of stuff. I was hoping to do more, but I don't trust this scale. So that's where we're calling it. Is the stream back? Are we good? Everybody see me? Just cut out for a second. Like what? Okay, cool. Cool beans. All right, outside we go. And away. I apologize in advance if this is super shaky, but it's just the way it is. Gotta take off my little booties. Where with you? Okie dokie. Biolab. Okay, over to the autoclave we go. I'm gonna just put you guys over here, and then let me get this loaded up. And then once it's going, I'll give you the tour. Apologies if it gets a little loud standing next to the air conditioner. I've already got water in here, so in case anybody's wondering. Man, I love these autoclaves. They're legitimately the bomb. I know a lot of people just use like a pressure cooker. Don't. This is worth the investment. It's a little pricey, but it's worth every penny. And it'll last forever. I mean, it's not a bomb. It's like, it's just a really, really nice autoclave. This one's actually a little nicer than the one we had in Florida. I don't know if it's just a different model or what the deal is, but it feels like the construction is a little better, which is super great. And yeah, this is all stainless steel, big old seal on it. I mean, here's the difference between this and a pressure cooker. Pressure cooker does not require 6 freaking bolts to hold it together. This gets to a much higher pressure than your standard pressure cooker, which means it also gets to a higher temperature, which also means, okay, plug is good, that it does a lot better job sterilizing stuff. Okay, and away we go. So I'm going to keep an eye on this while we go for a little tour, and hopefully it'll start doing its thing before this ends. Yeah, I mean, if it explodes, yeah, but it won't. The autoclave itself was only like $200, but because it was shipping to Canada, and also they decided to overnight ship a freaking autoclave, shipping was pricey, which sucked. But that's just kind of the way it is. Made of solid Nokia 3310. That's funny. No, it's not. That'd be way stronger. Okie dokie. I'm going to go over to the entrance of the lab and give you the tour from the walk-in. So this is the awesome entrance covered in many a sticker. I don't know. I like it. It's neat. So the itself has a couple of main areas where you can do different stuff. This is the new 3D printing section. So you got all our plastics up there. We got 2 different 3D printers, more plastic storage. In this corner over here is the electronics area. So there's kind of bits and bobs and everything you could ever need to do any sort of electronic stuff. There's power supplies and soldering irons and stuff to do reflow. So you can do like surface mount components, which is really neat, or remove surface mount components. Also, teeny tiny Tesla coil. This one's actually a 1 Tesla. So in theory, it does music. We'll get that going at some point. I was actually thinking of downgrading it. So just doing like a spark gap Tesla coil. So that way it's just like loud and mean, because I love those. So yeah, that's the electronics area. All kinds of really great stuff. And kind of the nice thing about FooLab and most hackerspaces, but especially FooLab, is that there's almost everything you could ever want here. The trick is you got to find it. So we're working really, really hard to reorganize the space and make it really nice and clean and easy to find stuff. But the amount of like interesting things I found just while I was cleaning has just been phenomenal. So, everything is kind of constantly going through cleaning and all of that sort of stuff. I have not wanted to ever make my own 3D printing filament because I've seen the people who've done that. It's a huge machine and their quality is inconsistent, which ends up killing your printer. So fuck that noise. Yeah, right. I mean, a little Slayer would be neat as well. I don't know if we're gonna put these online, but we've got a pile of old oscilloscopes for sale. I don't know. Anybody who wants one, send me an email. We got Pipsqueak just chilling. He's missing his head because the head is currently mounted on a separate stand so that we can do goes. Because goes doesn't move, doesn't require tracking. It's a point and don't touch kind of thing. Okay, moving along. So we're going into this room over here. So this is sort of it's kind of like the hangout area, but also it's a place where we can give talks. You can see the projector. So yeah, we're able to give talks, but also there is, there it is. Okay, I'll get closer and try and, there's this phenomenal rig for all of your wonderful VR needs. Now, a lot of people tend to use it just to like play games, but it's really here so that if you were ever interested in learning how to develop VR games, that's what it's here for, really. So if you're interested in developing VR stuff and you're local to Montreal, come to Foo Lab. Also, because we do a lot of brewing, at least once a month for the most part, we have in our fridge, oh, there you go, 2 beer taps, because we brew our own beer and our beer is on tap. So I think we've finished we finished one of them, but we've got another one ready to go. So I think in the next week or two we're going to be making a new batch. So that's going to be a lot of fun. And I mean, if you ever wanted to learn how to do brewing, this is the place to do it. And of course, for Halloween, we'll hopefully be making our glowing beer. So that's why I've been kind of pushing to get that project underway. Yeah, I mean, that's kind of this room. I mean, you can see there's a library of books behind me. There is an amazing collection of stuff back there. That's where the ham radio guide for like the study guide that I'm using was. There's also we've got a new edition coming in, which is How to Perform an Autopsy from 1950 in Polish, because nothing says hackerspace like doing an autopsy. Is a sentence that nobody should ever say. Yeah, I'm gonna come back around. I'm doing the loop. Also, this is a neat one. So this table, it's not plugged in at this particular red hot second, but it's an old Pong like video game cabinet. So when it's fired up, you can actually play like 4-person Pong, which is neat. Okay, moving right along. So the next main room is the workshop. This is where you've seen a lot of the videos lately. I do a lot of work in here. There's so many just phenomenal tools that are just an absolute pleasure to use. Of course, we've got our CNC milling machine, which I have abused the hell out of because I'm terrible at milling because I've only milled like a few things, so I'm still learning. But yeah, there's kind of every tool you could ever want. A wall of tools over here. So again, it's like anything you could ever really want to use is here. So, and also we've got tons and tons of materials tucked away, just all sorts of stuff, and materials are free to use. Basically, unless you plan on making money off of the thing that you're building, stuff's free. And if you're going to make money, just you kick a couple bucks back to the space. Just how it goes. But yeah, this is the workshop. It's a phenomenal place. Love working in it. And we're going to be getting a big metal lathe and mill soon, which everybody is super excited about. And that's going to be going where this cabinet is. Also, this pile of materials we're building more material storage that's going to go up in the roof. And so that's going to further neaten everything up. Over here is the beginnings of a welding station. So this is concrete board. So it's going to actually cover the floor So that way, anything that's going to get really, really hot can be done over here. So, your welding and blowtorches and general hot stuff goes here. So that'll be great. Moving right along, you can see that this is where the biospace is. Ooh, also, we found that this is what I mean by you can just find all this amazing stuff. There was just a guitar kit. So this is now got a bounty on it for, first person to make it into a really awesome guitar. Then we have a guitar for the space. It'll be great. So that's that. I'm gonna circle back around, and then all of this is either member storage. So once you're a member, you get a shelf and a bucket where you can put all your stuff and store your projects. But also there's a bunch of shelves that are just full of kind of spare parts and cables and anything you could need for your various projects. So that's always super, super great. Although you got to find the stuff first, which is always an interesting task. There used to, so where the biospace was, used to be more, or other way. This used to be shelving, and that was housing the museum, which was full of old computers. And we now have a guy who is in here like twice a week, basically reviving all of those computers. So they're all going to be, a lot of cool stuff is going to be done with them. So this is where all of the museum stuff is currently being stored. Every computer is being taken down, overhauled, made functional, and then this is going to be turned into a giant display. And of course, because it's a hackerspace, we have an awesome server room, roomy shed. But yeah, this is also gonna become a positive pressure room. Also filtered air, all this kind of stuff. This is our Paul. We keep him for decoration and also mostly software. Yeah, he's the one who's been helping me a lot with the software aspect of the various projects, which has been super, super helpful. And it is amazing what you can do with this amount of caffeine this man consumes. But yeah, that's kind of the tour. I'm gonna close this because it's really freaking loud because it's a server. Yeah, that's kind of the space. If you're ever in Montreal and you want to come see the space, it's open on Tuesdays and Thursdays. I would highly suggest you come by. Again, foodlab.org, all the information you can ever want about how to find the place. Also, that donate button, super important. But yeah, that's kind of the tour. I mean, I love this space. I spend so much time here just working on all the cool and amazing things that you've been seeing, and I am so forward. I'm looking so forward to doing so much more. Are we gonna try and fire up Pipsqueak, or do you want to?
Yeah, I guess you put the laptop there. We got to put the antenna on.
Okay, cool.
It'll run, I'm sure.
Yeah. All right. Cool. All right. So yeah, I'm gonna put the laptop down so y'all can see what we're doing, and we're gonna put Pipsqueak back together because dude needs a head. So y'all are gonna chill right here. All right. Cool. You can see everything.
It's the camera at the stream.
He does not accept butter donations, but he does accept donations of coffee in the form of money.
Wait. Stick the stream at the stream.
No, I am not. I'm not infinite streaming. Hi. This is the. Of course, we've got our corpse of Cogsworth. May he rest in peace. No Lacko brain. Honestly, since we built Pipsqueak, it's pretty unlikely that we're gonna fire Cogsworth back up. So he's just kind of become the space mascot. You can see he's missing an eye.
Space mascot is Cyber Ninja.
I don't know. He's got to fight Cogsworth. Cogsworth is more famous. I'm gonna grab a wrench.
Oh, I have the wrench right here.
Oh, do you? Oh, what a concept. You need an old. Yeah, I mean, we're not going to be doing this weekly. This was really like projects are difficult, so we decided to do something a little bit different. If we start doing streaming more often, we were going to use a different camera, but while we were testing it, it turns out it wasn't actually going to work for what we wanted to do. So in the future, for future streams, we will have a better camera and a better link and all that kind of stuff. We just kind of did it on a laptop so that it's free to move around, so I could walk around and show you the space. Bit lower. Better?
Talking.
Do you? Okay. Did you disconnect the cables first? Because that's important.
Oh, be careful. Okay, yeah, just get back.
That was not. Oh god. I
Right on top of it.
spoke too soon, friend. Hey, we gotta get this on just bit on first.
Tilted forward. Or do you want it up?
I'm gonna just get this piece on and then we'll go from there. Because this really needs to be secured well before we try and stick his face on. Or it just doesn't miss. Wrench.
Yeah.
Oh, I got it.
They're ready. What do you have?
No, you have a wrench. We're literally just using it.
Oh, right here.
Go.
So organized on live TV.
Yeah, right. I mean, it's almost like we planned this.
Yeah, it's almost.
You could almost be convinced that we planned this.
It's not at all how we work usually.
Nope. This is
A lot
totally
more public around.
fake news. Actually, can you hold this? This is cutting out my hands. Oh my god. Yeah, it's sort of like a sweet spot. If you tighten it too much, then it shrinks the hole. Warps it. Oh god. Okay. You want to take this down?
Okay,
Let's put her on the ground. Safety chair. How much is it?
It's heavier than me. Let's put that. No, it's not.
No, it's not.
No, it's
I
not.
watched you pick that up with ease. It is not heavier than you. It has eaten way less milk bars. Okay.
You should have marked the position shown.
What?
It's balanced with that.
No. I expected that to be shifted.
I planned for it. You built it. Yeah, you did build it.
I did, yeah. It was as if I spent 21 hours on this. Oh wait, I did. And then I spent another 21 hours.
Keep reading.
I spent 40 hours on.
Alright, that was good. Test. Bounce. Yeah, it's bounced down.
Enough to give it a try at least. Alright. Fire her up. Yep, it's not powered yet.
Yep, just look at all of them. Bring me the laptop. Second ring. But also need to fix this one. Thing meant to do and never did. Consistency.
I'm grabbing some chips.
Want to do that now?
Well,
Let's do it live.
I'm fixing the wire so that the fan runs.
Oh, yeah.
We meant to do that, but never did.
Sweet delicious. This one. Excuse me as I go and pray to the demo gods.
Yeah, right. We're doing it live. Nothing works.
Though, like, I saw the most beautiful thing back at Recon 2015, though. Guy had a backdoor on a firmware on a hard drive for the first time on stage. It was magical.
Yeah. That's what I was joking. She's taping that. I hate this connector, dude. I told you we should go with the soldered one.
There's still time. Okay, connected.
That'll do. Alright, give me a second. Let me just check the stream. Oh, good. It works. Thank God. Yeah, seriously. Alright, big test. Up and down. Yeah, it still works. Okay, it doesn't like that.
That's the balance again.
Yeah. Okay, go down. Okay, go up. 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 Over. Let's go all the way. Up. Up. I don't remember which way I'm supposed to move this when that happens. I feel like it's this way. Go.
Yep.
Oh God, did.
Alright.
So yeah, still works. By some frickin' miracle. A robot I built actually still works. Oh God, it can hear my thoughts. It can hear my thoughts. Okay, no, we're good.
Now put the knife at the end of it. It's telling you. It's telling you to do that.
Yeah. What's happening? Alright, wire in some wires.
Oh, no. What are we going to pick up in here?
I just noise. Turn the Wi-Fi up. Should we run the Conqueror program? Shabubi? What? Why does it always come back to Shabubi? Shabubi. Yeah, Shabubi. Also, I think it's totally running better since I balanced it.
Yeah.
Or since I funded.
Oh, yeah. Helps.
What helps? A thing that needs to run flat requires being level? Who'd have thought?
We need to experience perfect. Well, what?
Oh no, that's a very different build. That's a very different build.
Experience true level. Here at Full Lab. 3 spins, $99.99.
Through the hole with you.
Oh wait, doesn't this go with the autoclave?
Yes, bro.
I feel you're gonna need that in a bit.
Yeah, by the way, is the pressure going up?
It's at 115.
So yes.
I think. Should be.
Is it not at 0?
It's 0. It's a non-zero value. It looks like it's going up there, so yeah.
Oh yeah, okay, that's fine. Yeah. We'll hear it pop soon. Less good thing. this off later. There it goes.
I mean, which one do you want to run with Cogsworth? Because I would not run Cogsworth script against Tipscript.
This is true.
Because I calibrated the distances.
Yeah. I don't know. I'm gonna just open up STF Sharp and see if I see anything. Cool. I don't know, man. Doing it live. Making this up as we go.
Like scientists.
You mean like engineers?
That's reverse engineer to you, sir.
Got it.
I go the other way.
Isn't that just a?
It's engineering. More
It's
steps.
called a hammer.
Yes.
It's called a hammer.
From rapid deconstruction, binaries. Yes, we do make music in the space.
No, I'm not. I'm tempted to call him out on the stream just because Just to be clear, anecdotes do not equal fucking evidence. And if you know if I'm talking to you, you know if I'm talking to you. Idiot. Alright, what do you want to look at? What frequency you like?
Anyone want to suggest some frequencies in that chat? Like, it could be a little useful.
Let's just do FM. We'll just do FM.
Someone says 1 hertz. Yes. 1 hertz on that
No,
card.
you can't. It bottoms out at like
10. That's awfully specific. All right, Satan, get out of chat, please. Something over 9,000. That is a good point.
Can't do overnight.
For 20 gigahertz. Where would Ghost be theoretically if we could not see the signal from in here? That would be a miracle. Let's try and go for a miracle. No. Oh, we don't even have what's the max.
Where's all the radio? I can't hear it.
I said the splint. So
I don't see it. Alright, want to drive around, see if the signal gets better?
Oh, yeah.
Alright.
I meant to type Solon, okay? It's like,
Alright, so I've just got it aimed at a random radio station. We're going to drive the antenna around, see if it gets better. See if we can figure out where the station is. Alright, do you want to drop the elevation and then just let's start doing rotation and see if the signal gets better? Stop. Alright, rotation. Other way. Ooh, that is actually getting a little better.
It actually hit.
Oh. Okay, so I know you guys can't hear that because I'm explicitly not turning it up because I don't want to get dinged for like copyright shenanigans. But the radio station is legitimately getting louder, so it's over there apparently.
God, I feel like what's her name in Contact? Jodie Foster. That's it.
We picked 96.9. I want to look at all this that I missed. All right, this isn't really working. I'm going to turn it up to 2. All right, so we are now we're in Wi-Fi range here. I'm gonna bring the camera closer so you guys can see this. All right, so we got Cogsworth looking pretty. Those pulses are Wi-Fi. I'm gonna turn the sound off because it's Wi-Fi. You're not gonna hear anything.
Ooh, laptop to laptop is getting hot.
All right, you want to drive around a little bit? Actually, point it at the server shed.
We need to add more weight wheel.
Other way, yo.
Oh, this is true.
But also, actually, keep doing that. The pulses are getting louder. Remember that router we found? All right, keep going.
See it? No.
Yeah, it's getting a little better. Yeah, it does actually get stronger when you point it this way. Neat. All right, point at the server shed.
The other way.
I was like, what is that noise? Oh, it's the autoclave. Sorry for that loud noise, folks. That's the autoclave.
Sorry, the audience. Sorry, me. What? Ow.
Yeah, this is yeah, sorry. It does that. It should pop soon. I know. Sorry about that. I was not. I normally it just goes like whoosh, but this one is very, very.
First time we're running it.
Yeah, here. I'm gonna mute the thing for a second, so I can go check on that and don't kill all y'all. All right, so I think for the sake of all of y'all's ears, before that gets real loud, I think we might call it for the day. I hope you guys enjoyed. If you have, as usual, subscribe, like the stream, all that kind of stuff. If you want to see more behind the scenes stuff, because I know a lot of you have been saying that you really enjoyed this more like Cavalier behind the scenes-y stuff, Instagram, legitimately the best place to do that. I post there almost every day. You can see the projects as they evolve. That's always great. Again, if you would like to help the space, foodlab.org, come see the space, come see the workshops when they're up, donate to the space, become a patron, all that wonderful stuff. Thank you so much for tuning in. This has been a lot of fun. I hope to do this again. We're definitely not going to do this weekly, but definitely more live streams in the future. I'll see you guys around. Keep being turnips.